Hey guys, so I have created this brain for backend engineering, and this has all the knowledge that is there and indexed over. I have created an index over this, like this is a BM25 index that lets you get insight over whatever system that you are designing. Like suppose if I have to do a rate limit, mean like what all algorithms are there for rate limiting, I can just do rate limiting. Okay, so see, let's see what I got. Rate limiting throttling, uh, rate limiting, Apache Pulsar, JSON RPC, API keys, rate limiting abuse, rate limit per tenant, rate limit exponential back of jitters. Now let see if I want to do say Kafka. Okay, so the Kafka graph looks like this. So manage Kafka if you want to create. These are the things: data transfer between regions, GPU cost, uh, CloudFront cost. This is, I think, on the caching partition areas. This index is over Kinesis data stream. This is on SNS event bridge. So this is like a brain for everything that you need to know of Kafka. Let's do one more, and then I will deep dive into how I created this. Let's say we have to do DynamoDB. Okay, so this is the brain for DynamoDB. DynamoDB, then it leads to DynamoDB on demand pricing, DynamoDB provision versus on demand, then Cosmos DB, then Edge Kiwi Store. I think we can do a way more better. Say anti patterns. What are the anti patterns? Let's go anti. I think yeah, anti pattern. So if I just say anti patterns, okay, so let's see what is. So there is a god service, there is chatty microservice, there is time based cache. So you have a full vision. This library is like a map to everything related to backend and distributed system. So you can have this full vault. And so let me see how I created this. So I have this project. I've created this library called Backend Pro. Here you have multiple options. You can either run it locally, it's like a second brain, or you can merge it with your whatever models you are using. Now what all you can do in this. So suppose you are designing a backend system and you want to know, like, so have some query like say Kafka. If I have like to design a Kafka once delivery system, what all I need to do, what I don't need to do, right? Those kind of, you will have to reach out to your seniors and all, but this will give you that insight beforehand. Or if you have to do some whenever you're designing a system, you have to do a, like a comparison between a trade-off between, like, should I use Kafka, should I use RabbitMQ. So that will give you, like, this will give you a complete table. Okay, why throughput is better in Kafka, what kind of partitioning is there in Kafka compared to RabbitMQ, can you replay your data and all. Then you have an interactive way also if you want to create or design something. And then you have like, and there is also inbuilt function that, like, suppose you have to do a comparison but you have some constraint that you are using certain library, you are using certain, you have so that you want a high throughput, you want high availability, so you can pass those kind of information also. So this current knowledge base has like 20 domains and 12 stacks that are there. So these are all the pattern database, messaging, performance, testing, architecture, data, ISE. And then there are 12 stacks. It has knowledge of all these languages: Golang, Java, Python. You can ask query on anything. There are, these are the ways how to use. You can compare. What you can do, you can run it in interactive mode. You can check freshness also. Like suppose a new data has come in, and what you are, the design that you are proposing is kind of a old deprecated design. You can check that what all I want to design should be latest, just 1 year only, anything that has been updated, right? So you don't end up designing on the old. Then you get a confidence score also, that how confident the system is around that design, so that you can make that decision. You can do your validation, you can cache this index in your system and then create a similar old. You can decide, you can create full design diagrams, and you can create uh, a PostgreSQL, like you have to you can create full designs. and then this is how the usage will look like, and this is how you can integrate with all the design. Let me show how I used to create one design for this. I have a GitHub for this. Yeah, I have one system design, maybe somewhere I can show. um, docs. I use this to create a Netflix design. So this is a Netflix staff level in a system design, and everywhere you go, like I've got fed up. Like all of these sites, they give you very like suppose Netflix has a lot of good engineering blocks. Your everything what I have learned in the software, everything that you quote in design should be verifiable by data. It should not be random. Like you cannot say this works better than this. What is your citation, what is your source of that information? So this system design I created using this library, and this is how Netflix is created. Let's go through it. These are the functional requirement user, and these are non-functional requirement on availability and everything. These is back of envelope calculation. This is the architectural decision records. These are the ARDs. I'll show by a diagram. So this is the diagram that is there for end-to-end system overflow. Now this is very advanced compared to anything that you can get. Like suppose you're just database layer. If you have to see, right, so backend and front end, if you have to just design the viewing history service, you are using Cassandra. There in any system you there are multiple DBs that are always there. You have a caching DB, you have Elasticsearch to have a better retrieval systems, you have MySQL for metadata, or like a cockroach DB it recommended, or like in other companies like in AWS mostly it's DynamoDB. So now this is the first draft design. Like suppose I had a constraint that I want to use only AWS to design Netflix, then I can have a very separate design. That is my constraint. If I am using only Azure, then that is my constraint. So you can have designs that kind of uh, dynamic system designing is not still available, and day to day basis we have so much constraint that we do when we develop a system. These are your uh, flow diagrams for press play component. Zool is just for like key delivery, and then this is your recommendation system design. Now this is like, and this is your data topology. If you can deliver 50% of this in an actual interview, and if you understand this at this level, then you, and this, it's not whatever it has created, this has a reference that this is the data that I have used. How it works is that there is a secondary BM25 index brain that is there, the brain that I showed you, this brain. uh, yeah, so this brain that is there, and I can, let's do one more. I want to do, say, caching. Okay, so this is my caching one. Let me see what is there. There is a time-based caching, and what is it in time-based? Event-driven architecture. There are indexes on this materialized view, event sourcing. Let me just open one. So in each of the file is designed in a way that when to use, what to use, what are trade-offs. So this is very deterministic data, and when it was last published, and what is the source of this information. So whatever, when you use that constraint of I want only one, your graph is created in that way. When you have a constraint, then it creates it's a very dynamic knowledge brain that is there, rather than just relying on a LLM model that will just like only give you like highly probable data. So yeah, this is how it is. Okay, let me close this.